Welcome to part 2 of your stoichiometry notes. Hopefully learned a little bit from your first one. Second video here is going to be doing some practice problems. We got 2 practice problems for us to go over here today, so let's continue on here. Do we normally measure in moles? No, we measure with grams. Well, why would we measure with moles? It's hard to do. Okay, so we're always converting our numbers. We take our numbers from grams and we turn them into moles using our periodic table and our molar mass. Okay, so let's go through a stoichiometric problem and see how we can solve it. Okay, first step is to write the balanced equation, and then ask yourself, what are the given? What do you want? You need to figure out what you're going to start with and what you're going to end with. It's very similar to our unit conversions. Okay, and then you need to convert and solve for answers. So basically, these are very similar to our questions we did with converting from mass to grams and grams to moles and things like that, but we have an extra step. Okay, let's take a look here. During photosynthesis, plants use energy from the sun to produce glucose. Okay, glucose and C6H12O6. Anyone get any flashbacks from biology? And oxygen from the reaction of carbon dioxide and water. Take a look down here. We can see this is the equation we talked about before. This is our photosynthesis. 6CO2 plus 6H2O equals C6H12O6 plus 6O2. Okay, so that's our equation here. It's already balanced, as you guys probably remember. The question is, how many moles? So what is the mass in grams, of glucose that is produced when 3 moles of water reacts? Well, first we write our balanced equation. Okay, that's done. Now let's take a look at this. Go through step by step here. Okay. First, we need to figure out what we have and then what we want. Okay. First off, we need to have, we are given, 3 moles of water. Okay. And we need to get our molar mass for glucose. Okay. So right down here in the bottom, you can see here, we've got our mole ratio between water and glucose. This is directly from the formula. Okay, remember there's 6 water molecules for every molecule of C6H12O6, glucose. In other words, there's also 6 moles of water for every 1 mole of glucose. And over here we have our molar mass of glucose divided by 1 mole. These are both equalities. These are both equal to the same thing. Okay, so we're going to start off with moles. Okay, we start off with 3 moles of water, and you can see here that 3 moles of water, we're going to multiply by this equality right here because we want to cancel out moles of water. That's why we have the moles of water on the bottom and moles of glucose on the top. And over here, that's why we have the moles over here on the bottom here, is because we have moles on top over here because we want to cancel them out. Okay, because we're going to get moles of C6H12O6 right here, and then we're going to get grams in the end. And grams is what we want. Perfect. So we'll multiply all the way across to get our grams, 90.1 grams of glucose. That's our final answer. Okay, let's take another question here. Second question is, the reaction between powdered aluminum metal and finely ground iodine is a vigorous synthesis reaction. Synthesis, making into something new. In this situation, we are making aluminum iodide. Okay, how many grams of iodine will be made from 35 grams of aluminum? Okay, so the question here is how many grams of iodine are we going to use? Okay, because remember, we are taking this iodine and we are going to make some iodine. So the idea is, how much do we need of both? Okay, so let's write our balanced equation here. It says here that we have, for every 2 moles of aluminum, we're going to need 3 moles of iodine to make our aluminum iodide. Okay, and we're going to get 2 moles of aluminum iodide. Okay, that's our balanced equation. So we're going to start off with our aluminum, and then we're going to end up with our iodine. Now we start off with grams. We have 35 grams of aluminum, and we're going to end up with iodine in grams. So we're going to have to do a gram to mole to gram conversion. This is probably the most common way that you can do stoichiometry. And it's probably the most useful too, because it actually is what helps you actually figure out how much material you need to do a whole reaction. So let's take a look at some of these conversions down here. Okay, we're going to figure out the moles of aluminum, then we're going to figure out the moles of iodine, then we're going to figure out the grams of iodine. Look down here. We start off with our 35 grams of aluminum. Then we use our mole ratio. This is the molar mass of aluminum over underneath 1 mole of aluminum. Okay, these cancel out, grams of aluminum. This is an equality equal to itself. Okay, Then we're going to multiply by the mole ratio. Okay? Now, this 3 and 2 can be switched around. We could have iodine on the bottom. We could have aluminum on the top. It doesn't matter. But here, we have 1 mole of aluminum on the top over here, and we want to cancel them out. So we are putting this 3 goes from right here, 3 moles of iodine is equal to 2 moles of aluminum. So this is equal to 1. So this is another equality. Okay, and that cancels out our moles of aluminum. Now we have moles of iodine. How do we get to grams of iodine? That's right, molar mass. Okay, so for every 1 mole of iodine, we get 253.8 grams of iodine, and that is our answer. 494 grams of iodine. Hopefully this made sense. Go ahead and watch this video again if you weren't sure. There's one more kind of example that is on this slideshow. I want you to take a look and read over that. And I'm going to assign you a couple of practice problems here on Google Classroom as well. You probably already saw those. Take a look at those, answer those questions for credit today. Please let me know if you have any questions in the comments, or send me an email, or visit office hours all this week from 1 to 2 p.m. All right, guys, have a great day. Thank you so much for watching. Bye.